Let's take a look at exit slip 3 on absolute value functions. For this exit slip, we were asked to solve an absolute value inequality. And there are several ways you can solve an absolute value inequality. I'm going to share what might not be the most efficient, but I hope it's a method that can make some sense. So often what I do with inequalities is I consider the corresponding equality. So what I mean by that is, let's say that it was the absolute value of 2x minus 7 is equal to 5. We know that to solve an absolute value equation, we need to consider when the output of the absolute value is positive 5. And then we need to consider, really, I should say, when the input is positive or negative 5, because the absolute value of both would give us positive 5, right? So again, kind of the idea here is if we can get the inside of the absolute value to be 5, the absolute value of that is 5. If we can get the inside of the absolute value to be negative 5, the output of that is 5. So that's why I've set up my two equations as I wrote here. And I've seen some of your work, you guys have slightly different approaches that are still totally valid. So definitely some options with solving, right? I like to say do your own algebra dance because there's not necessarily just one right way to get there. So you can take these ideas if they're helpful or use strategies that you're already familiar with as well. So I'm just going to finish solving for x in both equations. On this first equation, I'm going to go ahead and add 7 to both sides, divide both sides by 2 to get x equals 6. The second equation, I'll add 7 to both sides to get 2x equals 2, divide both sides by 2 to get x equals 1. And if the exit slip was truly just solving the absolute value equation, we would have our two solutions. And remember, graphically, what that means is it's essentially saying where does the graph of this function intersect with the horizontal line at 5. So for those of you who like the visual, there's a lot of good visual understanding with solving. But we are asked to solve the absolute value inequality. So what I do next, and this is what I've shared in previous videos, is I just place the values we found, 1 and 6, on a number line. And what I need to do now is test some values of x to determine which interval or intervals create true solutions for the inequality. So for example, you can tell a value like x equals 2 is clearly between 1 and 6. So if I test 2 in the original inequality, that would mean the absolute value of 2 times 2 minus 7. And we're asking ourselves, is it true or false that that's less than 5? So to test x equals 2 means to plug 2 in for the value of x in the original inequality. So I'm going to keep working this out. 2 times 2 is 4. 4 minus 7 is negative 3. And the absolute value of negative 3 is 3. So is 3 less than 5? Yes, that's true. So what that means is that, that means the values in between 1 and 6, but not including, because it's a strictly less than, these are all going to be values that satisfy the absolute value inequality. So our solution can be expressed either as an interval or using inequalities. I could say all x between but not including 1 and 6 are good, or I could say the open interval from 1 to 6. So notice I'm using parentheses here because we are in a strictly less than scenario. That's true for strictly greater than. If we had less than or equal to or greater than or equal to, that's where we're going to have brackets involved. So just a friendly reminder about that. So that would be our solution. I'm going to pop out and graph it real quick, come back and just share the graph as a check for the work that we just did here.